that raises geopolitical questions. What do we do the day after we find an interstellar object that is recognized as technological? And there is no thought about this right now because we regard as existential threats artificial intelligence, global climate change, or impact by asteroids, rocks. And we are trying to plan for these risks, but nobody is talking about alien technology.
Today's episode isn't about panic, it's about preparedness. The interstellar object 3I Atlas, only the third confirmed interstellar visitor to our solar system, will swing past the Sun on October 29th. NASA says it poses no threat. But as a stress test, how would humanity react if such an object turned out to be technology? Our returning guest, Professor Avi Loeb of Harvard, is one of the world's leading astrophysicists. He chaired Harvard's astronomy department, leads the Galileo project, and has spent years challenging orthodox thinking on interstellar visitors like ʻOumuamua. Whether you agree with him or not, when Avi Loeb says we need a plan, people pay attention. Here we'll unpack his provocative 15-point proposal, a link to which is in our show notes, spanning science, law, and geopolitics, and ask, are we ready? This is bigger than democracies versus autocracies, bigger than war and peace. It's mental red teaming to see whether humanity today can cooperate for the greater good if confronted with the ultimate unknown, that we are not alone. Avi, welcome back to The Focus.
Thanks for having me. It's a great pleasure.
Avi, your core claim is preparedness, not panic. In one sentence, what's the minimum no regrets action the world must take before the 29th of October 2025?
Yes. So first I should say, when NASA says this object poses no threat, they assume that it's a rock, or they argue that it's a rock. Either way, we can sort of forecast where it will go based on the law of gravity. But a technological object is very different because it can maneuver and it could have some purpose for coming close to Earth that we cannot anticipate. And therefore, it's a whole new ballgame. And we are talking here about a blind date of interstellar proportions. Of course, it could be a rock arriving from another star, but if we look at the data, there are reasons to worry. And I can mention a few of them. One is that the object reflects sunlight, and if it was just a solid object, it had to have a diameter of 20 kilometers. That's bigger than Manhattan Island and twice as large as the rock that killed the non-avian dinosaurs 66 million years ago. So these rocks are very rare. And the previous objects we saw from interstellar space from outside the solar system were much smaller by a factor of 100. And so the question is, why is this one so big? And we should have seen 100,000 small ones before we see one that is 1,000,000 times more massive than the previous ones. So that's one issue about it. And then we don't see a cometary tail behind it like we see around comets. There is some glow of scattered light around it, but it precedes the object as it moves into that glow. And that's unusual. And moreover, the trajectory of this object is fine-tuned. It lies within the plane of the planets around the sun, within 5 degrees. And the chance for that alignment is 1 in 500. We didn't have 500 objects before we found this one. This is just the third interstellar object. We know that it's interstellar because it's moving very fast, much faster than the previous ones. 60 kilometers per second. It passes in 1 second the distance that a car passes in an hour. And moreover, it will come very close to Mars, Venus, and Jupiter. if you just adapt the orbit that it takes and randomly choose the arrival time of the object, there is a chance of 1 in 20,000 that it will be so close to those 3 planets. And so that's really a very fine-tuned trajectory. And the question is, was it designed by some intelligence? Now, of course, it may be a rock that is unusually large, that happens to be on a path that happens to lie with the planets, and it passes by chance near these 3 planets. But we need to get more data on it to be sure that it's natural. And I suggested the scale where 0 would correspond to a natural object that is definitely a comet, let's say. As it comes closer to the sun, it may start outgassing, and we would see a beautiful tail behind it. And 10 on that scale corresponds to a definitely technological object that maneuvers, broadcasts a signal, or emits some artificial lights. And this is now called the Loeb scale. There was an article about it on the preprint server in astrophysics. And the question is what to give, what kind of a rank to give 3I Atlas, this new object. And I suggest giving it a 4 between 0 and 10. So it's not yet clear that it definitely possesses some technological feature, but we have to be alert to that possibility. And in the coming decade, the Rubin telescope in Chile that was just inaugurated in June 2025 will be able to find a new interstellar object every few months. And of course, we can assume that all of them are rocks of the type that we find in our backyard, familiar rocks, icy rocks. But among them, we might find a tennis ball that was thrown by a neighbor. And that raises geopolitical questions. What do we do the day after we find an interstellar object that is recognized as technological? And there is no thought about this right now because we regard as existential threats artificial intelligence, global climate change, or impact by asteroids, rocks. And we are trying to plan for these risks, but nobody is talking about alien technology, because if something like that happens, of course, that would be a wake-up call. And I think we need this wake-up call because I don't think our political system or policymakers would attend to this matter unless it's urgent. And if something comes to our backyard, we better respond to it because it may enter through the front door. And it's very different from getting a radio signal from some source that is thousands of light years away, where you have the leisure of thinking about what to do, without being concerned that there would be implications in the immediate future. So what should we do? And I wrote a full essay and then elaborated on it in an article where I suggested, that we should adopt the scientific approach where the response must reflect specifically the detailed characteristics of the threat. Because it's very difficult for us to imagine technologies that we don't possess. And, if those aliens had more than 1 century of science and technology, the way we did since quantum mechanics was discovered, they might have developed things that we don't even imagine. And so like in any blind date, my approach is to advise whoever is in a blind date to observe before having an opinion, before deciding what to do about it. And once we collect enough data, then we can, and this data should, of course, use all the telescopes that we have, all the space assets that we have that are currently employed for intelligence gathering and other national security priorities. So we should get as much information as possible, and that should be shared by all humans, because the response that we take would affect everyone, and all nations must cooperate with each other on a coordinated plan, and it must be based on the understanding that we're all in the same boat. And if one of us rocks the boat, all of us might be at risk of drowning. And the plan should include the activation of space, air assets that we have as the human species rather than any particular nation. And no nation should take advantage of this situation to hurt another nation. And of course, we should avoid the violence of humans against humans by punishing whoever misbehaves. And there should be a committee, an international committee that decides how to communicate with such a technological device, and it will employ the best tools that we have, AI tools that are available to decode any messaging that we get. And of course, the issue is that as the situation evolves, governments will have to cooperate and be in continuous contact, because whatever happens at one place affects everything that happens at another place. And one should obviously ban any pirate messaging or engagements with the threat, because that could sabotage any such interaction. And then once the dust settles and the threat is resolved, we should learn the lessons from it. And some of the lessons are, to build for future visits, to build new astronomical observatories that will assess and alert us to future threats based on the experience we had. We should also have an array of space-based interceptors that should be installed in orbit around the sun, and the spacecraft that is closest to the path of an incoming alien device should approach it and tell us more about it, perhaps take a close-up photograph. Because as of now, all we think about are, rocks that are moving on predictable trajectories. And in this case, we really need to be alerted to something that is more intelligent. And my recommendation is that, a fraction of the $2.4 trillion that we currently allocate to military budgets worldwide would be redirected to the development of new defense technologies and the related scientific research with a long-term view. These are studies that were not done before, like how to create an umbrella of interceptors that will protect us. And finally, it will give us a priority to engage in space exploration, either in the form of scouting missions that will study our cosmic neighborhood, but also in addition to defending Earth against predators, to also send sustainable habitats on space platforms that humans occupy, so that if something bad happens on Earth, humanity will continue. So this is sort of the big brush picture of the way I think about it, but there is not much discussion so far. And, this should be coordinated internationally.
Okay, so a couple of things just off the top, Avi, if I may. You've mentioned a number of times threat and predators. Is there a reason why you suspect, or why you're using these particular words as opposed to opportunity for discovery, or something that is a little more benign as a descriptive? Because at the moment, threat and predator doesn't sound good. Can you explain that?
Right. So first, I should say this is all in the context of what is called the dark forest hypothesis, which is a solution to a paradox that was raised by Enrico Fermi back in 1950, when he was having lunch at Los Alamos with colleagues discussing extraterrestrials, and he asked, "Where is everybody?" And one possible answer is that the aliens are not visible to us because they're silent. They're actually nearby, and they're listening to us. They are worried about predators, just as if you are in a dark forest. You don't know which animals may endanger you, and so you keep quiet. And so they do that, and they still monitor us. But we were careless. We transmitted radio signals, so they know exactly where we are, technologically speaking. And once we advance to a level that poses a threat to them, they might pose a threat to us. And or do some reconnaissance missions. So that's the context. But I should say, we don't know. It may well be that they visit our immediate neighborhood just as a matter of exploration, or actually maybe even to help us. The reason I mentioned threat is twofold. And actually, one is that otherwise we won't be motivated to actually do our best to identify them and perhaps communicate with them, because the humans often respond to a threat much more vigorously. And actually, the fact that I mentioned this dark forest hypothesis a month and a half ago in a paper resulted in this subject becoming viral on X, and as well as on many other social media platforms. And reporters keep asking me for interviews nonstop every day, and people read. Over the past few weeks, almost 500,000 people read my essays that I post on medium.com. And all of this attention comes from the possibility that it might be a threat. If I were to say, imagine an opportunity for us to learn about some new technologies just by observing a spacecraft pass near Earth, it would have been less of a viral interest. And I got even a message from someone who read my papers, and he said, and I wrote more than 40 essays since 3I Atlas was discovered over the past month and a half, and also about 5 scientific papers about it. But actually, by now it's 6. Someone wrote to me that he is investing in options on the volatility of the market with an expiration date of the 29th of October 2025, when it will become clear whether this object is actually maneuvering. When it comes closest to the sun, that's the optimal point for maneuvering, taking advantage of the sun's gravitational assist. Or it might release some mini probes that visit Earth later. But at any event, that would be a dramatic development in the history of humanity, and it will change the future. And obviously, the stock market might be volatile as a result.
Avi, what would an interstellar technological object look like if it's undergoing deceleration as it enters the solar system? I mean, we were talking earlier about the fact that we see this thing. It could be a rock, it could be something unknown in terms of our capacity to understand how things operate at interstellar distances. But if we were to, just imagine for a moment that this is an artificial object and it's traveling at breakneck speed, it's going to have to slow down at some point. So what would a decelerating interstellar object that's technological look like? Would it look like 3I Atlas?
Well, so first, let me just complete the second point that I mentioned. So the reason of speaking about a threat is that sometimes if you are naive and you believe that, they're very friendly and you accept them with open arms, it may be actually a Trojan horse. And that's what happened to Troy, that in the... So you have to be suspicious as a matter of survival, protecting yourself. And so that... But in terms of maneuvering, a spacecraft often, if they have an engine, it's best to operate the engine when they're moving fastest or accelerated to the highest speed. And that happens closest to a massive object like the sun, for example. And we use that, for example, to accelerate spacecraft that we launched out of the solar system. So when they pass close to the sun, if you fire the engine such that in the direction of motion of those objects, you increase the kinetic energy, the ability of the thrust to propel this object out of the solar system. And if, on the other hand, you fire the engine in the opposite direction, you can slow down. And so that's why perihelion, the closest approach to the sun, is an important point. And as it turns out, on October 29th, this object would be on the opposite side of the sun relative to us. And here again, one asks, was that planned? Because we won't be able to observe it at that very crucial moment. But of course, if it doesn't come out on the other side the way we expected, the stock market indeed may crash.
Okay, on that cheery note, we do have planetary defenses, though, Avi. We've got NASA's Planetary Defense Coordination Office, the International Asteroid Warning Network, and the Space Mission Planning Advisory Group for International Coordination. But they're, as you say, aimed at rocks, not maneuvering tech. What's the fastest way to repurpose that scaffolding for a technological threat?
Yeah, so that really depends on the technology. When you have a visitor in your backyard, the response must reflect the intent and the qualities of the visitor. You can't decide, to shoot at all visitors the same, or to welcome all of them, or you have to assess what the visitor is like. And that's what makes it so difficult, because we are familiar with the kind of technologies that we possess. And the sky's the limit as to what our neighbors have. So if they have similar technologies, we will be able to figure out exactly what to do. But otherwise, it may look, it may appear to us just like the B-2 bombers appeared to the Iranian air defense system. They couldn't do much about it. And for example, this object, 3I Atlas, is moving, it will move close to the sun at 68 kilometers per second, and the Earth would be moving in the opposite direction because the trajectory is retrograde.
That's right.
So the two objects will move relative to each other at 98 kilometers per second. That's 3 times faster than our fastest rocket ever. And there is no way for us to intercept it. I actually recommended using 2 existing spacecraft, one around Mars that has a camera of 0.5 meter. That's the Mars Reconnaissance Orbiter. And when 3I Atlas comes within 29 million kilometers from Mars on October 3rd, 2025, then this camera could resolve 30 kilometers around it. That will be the size of a pixel. So that would be really interesting. I encourage the team that operates this camera to use it, and they agreed to do that. And then there is a spacecraft around Jupiter called Juno. Juno was the name of the wife of Jupiter in Roman mythology, and this spacecraft was launched in 2011, and was supposed to end its life in mid-September 2025, just very soon. And I wrote a paper in which I suggested, instead of pushing it into Jupiter and killing it, let's push it away from Jupiter so that it will come close to 3I Atlas when it gets closest to Jupiter on March 16, 2026. And I was in communication with a Juno team, and I hope they will do it. A day after I wrote the paper, Congresswoman Anna Paulina Luna called me on the phone and asked for a briefing, an update on 3I Atlas. And I mentioned also the opportunity of using Juno. So she wrote very generously, wrote a letter to the head of NASA, Sean Duffy, the transportation secretary, and urged NASA to use Juno to probe 3I Atlas, because it's really important to get as much data as possible. Just to give you an example, I get a lot of emails, but every now and then there is a jewel. So last night before I went to bed, I got an email saying, I'm a former pilot in the US Air Force, and my daughter watched you on television, and because of you, he says, she's now completely fascinated with becoming a scientist, and she's talking about aliens all the time. And I found that to be amazing because I really lost hope of convincing my senior colleagues that this is something we should do. They are pretty much entrapped in echo chambers of rocks in space and physical. They don't think about searching for alien intelligence before finding microbes. So they just focus on microbes. But young people, my hope is with the young generation that is far more imaginative, creative. They didn't, they didn't lose their curiosity, and so I'm really delighted to hear this story. And when I responded to him, he said that she's now going to brag with her friends that the real Avi Loeb spoke with her. So that was great. That was last night. But then this
Yeah.
morning, I got a question. Is it possible that the 3I Atlas is made of antimatter? Now, antimatter is an excellent fuel because if you mix it with matter, you convert all the rest mass into energy. E equal mc squared. That's Einstein's formula. And that is the best fuel you can imagine. There is no fuel more efficient than that, getting pure energy out of mass. It's a huge amount of energy. I just think that the nuclear explosions make use of maybe, I would say, a fraction of a percent of the mass that is being used in the weapon. Okay? And so here you can use 100%. For peaceful purposes, right? Just to propel a spacecraft. But the question was, what about if the spacecraft itself is made of antimatter? Now, there was not much that survived following the Big Bang because the universe was very dense early on, and all the antimatter was annihilated by matter, so nothing was left. And the only way to make it is by some energetic processes, like if you invest a lot of energy in a small volume, you can end up making some antimatter or radioactive decays. At any event, the CERN, the accelerators at CERN produce antimatter, and 1/100th of a nanogram of antimatter costs like a kilogram of gold to make such a tiny thing. 1/100th of a nanogram, at 10 to the minus 9 of a gram, is worth as much as a kilogram of gold. And if you wanted to make 1 gram of antimatter, it would cost about $5 quadrillion. Quadrillion is 10 to the power 15. So for us, given our technological advances, it's completely impractical to use antimatter as fuel because you need to make it, you need to store it, it needs to be large quantities, and our economy cannot allow for making even 1 gram of such fuel. Now, maybe the aliens are more advanced. So I calculated before my morning jog. I jog every morning before sunrise, but just before that, I calculated, okay, well, suppose it's made of antimatter. Suppose they managed to do that. How much power will be generated as a result of the fact that this vehicle, this object, is scooping material in the solar system? And I found that it actually matches the luminosity from this object, except you would get it in gamma rays and X-rays if the annihilation was seen directly. But if there is a blanket that converts it to visible light, then it gives just the amount of power that we see coming out of 3I Atlas. So that was an interesting result, but I think it's very unlikely that another civilization managed to make something out of antimatter. So I would not consider that seriously.
Okay, well, Avi, the International Academy of Astronautics post-detection non-binding protocols say don't respond to ET signals until international consultations, in theory through the United Nations. Should we codify that into law now? And if so, who writes it? Is it
Okay,
going to be, yeah.
so The situation is similar to someone who decides about a protocol. This is similar to the protocol of SETI, where if you get a radio signal from thousands of light years away, you have plenty of time to respond. So imagine that there is a guest that shows up close to your front door, okay? And you say, okay, wait a minute, I have to assemble my family, and I need to form a committee that will sit around the table for hours and decide what to do with the guest. I mean, that is clearly unrealistic because the guest might at the same time enter your home. Okay. And so, of course, you have the leisure of establishing committee. And by the way, my experience with committees is that, the only way to make it efficient is to have a committee of one. If you make a committee of tens or hundreds of people, it would take much longer than you expect. And the decision will reflect the lowest common denominator. Because it's the central limit theorem in statistics that you average out the votes when you make a decision. Now, sometimes it moderates, you don't get extreme decisions, but in a situation where decisions need to be made fast, you don't want someone to open a book and, okay, here are the guidelines. It will take us several months to assemble those people, put them together, then decide what, because the event itself may last just a few weeks or days, or who knows. And so it needs to be faster, and it needs to be attentive to the specifics of the encounter, because again, our imagination is limited to our experience on Earth, and that will be the basis on which we will think about response protocols. Okay, so but imagine that if you have an antimatter spacecraft visiting you, or if you have something that moves close to the speed of light, or if you have some amazing manipulation of space and time by a highly advanced technology that we cannot fully comprehend. In each of these cases, the response would be a very different response, and there are so many possibilities. Because I mean, just look at science fiction stories. They span a vast array of stories and possibilities, and many of them are not even based on science. They're just in the imagination of. So what I'm saying is that even the best script writers in Hollywood are not as imaginative as the aliens might be, and therefore
I agree with that.
And therefore we should observe, like in any blind date, before we decide how to respond. Now, there needs to be an organization that in real time, just like a war room, in real time, and that happens in countries when there is an urgent situation, right? In the context of a war that just broke, or so you have a number of representatives that take decisions of how to respond to an urgent situation. But in this case, unlike other conflicts or threats that we have on Earth, which are usually originating from humans, or doing something where we pretty much know what the kind of technologies they have and how they operate. In this case, we will have to rely on the best data we can assemble. So the first step in the process is getting the best intelligence we can, and that should come from all assets that humanity has. We should not make a distinction among nations, and we should all work together and collect as much data as possible, all nations, and bring it together to an organization that makes a decision of what to do. And then all the data should be shared, by the way. It shouldn't be classified, because humans will have to be aware of what's going on.
It's very interesting, but there are a couple of practicalities that get in the way of a lot of this. That is, your Principle 13 proposes space-based interceptors, and we've discussed this earlier, that could employ nuclear weapons. The Outer Space Treaty Article 4 bans weapons of mass destruction in orbit. So how do you square your plan with black letter law? And if it can't be squared, what's plan B?
Well, these interceptors will not be in orbit around the Earth. So I think the restriction is on things close to Earth. But if we are intercepting an interstellar object far away from Earth, I don't think there is any legal system that applies to that. And of course, getting those nuclear weapons away from Earth to space might be the issue, to make sure that there are no accidents, that nothing falls back. Um, but that can be accomplished. And in principle, once you deliver those assets to space, they would be very far from Earth. The space is vast, and it takes 8 minutes for light to arrive to Earth from the sun, our closest star, and it takes 4.25 years for light to arrive to us from the nearest star. And so, the size of the solar system is about 100,000 times the Earth-Sun separation. That's the edge of the Oort cloud, the outskirts. And from that distance, it takes about 2 years for light to arrive to us. So, these are vast scales. If you go all the way out to the edge of the solar system to establish some kind of an alert system, any signal sent from there will take a couple of years to reach us. Of course, that's at the speed of light. So, we will still have a lot of time. 3I Atlas, in particular, entered this boundary of the solar system at 100,000 times Earth-Sun separation, entered it 80,000 years ago. So just think about it. If we had an alert system 80,000 years ago, it would have sent us a signal that would take 2 years to reach us, and then we would know that 3I Atlas is making its way towards the center of the solar system. So for 80,000 years, we would wait for it. And
Wow.
instead, right now, we just found it when it's within 4.5 times the Earth-Sun separation. Even though it's 20 kilometers in diameter, if it's a solid object reflecting light, if it were farther than 10 times the Earth-Sun separation, no telescope on Earth right now could have seen it. So there could be a fleet of those spacecraft, in the spirit of the dark forest hypothesis. We don't know where they're parked, and if they're parked at 1,000 times the Earth-Sun separation, it would take them 80 years to reach us with the speed of 3 Atlas. If they're parked at 100 times the Earth-Sun separation, that's the Kuiper belt. That's sort of the farthest distance that we can see with telescopes of, planet-sized objects. At that distance, it would take them 8 years to arrive to us at the speed of 3 Atlas. So we don't know what lies in our cosmic neighborhood because we can't survey it with telescopes on Earth, and we should have some scouts, telling us what lies in our cosmic neighborhood.
Space is vast, and it's not just space, it's time, as you rightly point out.
Yeah,
So, how
yeah.
we overcome all of this with current technology is anyone's guess.
But
So,
but also
Avi, oh,
I should also mention that suppose you had a legal system that says something about what you're allowed or not allowed to do uh, at the edge of the solar system, then reaching whoever violates the legal system out there and policing what happens and punishing whoever does it is completely impossible. And
mm,
also
mm.
it might be too late. By the time you arrive there, nobody will be there.
Well, not only that, but just continuing on that thought bubble, that is that over time things change and our priorities might change, say 50 to 100 years from now, even 10 years, maybe even five. So
Yes.
again, there's you want to put all these long range um, processes in place, but again, that's supposing that human nature is going to be able to maintain itself for the duration of this project, if you will. And I'm
Yeah.
not sure
So
whether it can.
Yeah, so just communicating with a round trip message, like
Mm,
suppose you send a message to a spacecraft that is at the edge of the solar system, you're waiting for the response. That takes 4 years, and that's the duration of a presidency in the United States
exactly right.
for
Exactly right.
one message. Okay,
Yep.
so my point, I mean, the scale of space and time, is vast, even even
Mm,
within the solar system, and we should get used to that. Now we
mm,
keep thinking about the small rock that we were born on, and that obviously makes sense because that's what we know. But if we look up, we might realize there is much more real estate out there that we should explore.
mm,
And we started our journey of humanity in the jungles of Africa
mm.
and on trees. And eventually, after millions of years, we made it to high rises in cities. it's a very different environment. You don't need to fight for food that nature gives you. You can order it and it will be delivered to your apartment.
Mm.
Now, my point is that venturing to space, bringing humans from the high rises of cities to space is less of a leap than going from the jungles of Africa to high rises in cities. And therefore, if we just put our attention to it, if we invest a fraction of the $2.4 trillion a year that we put into military budgets, if we invest that in space exploration, we can definitely do it. It's just a question of priorities. Instead of killing each other, we should cooperate. That's not so complicated. I mean, of course, it's against human nature because we are used to the psychology of fighting for limited resources, in the jungle. And what the vision of Elon Musk of going to Mars is not that visionary. It's we are born on this rock that we call Earth, and we are thinking of going to another rock. And actually, the conditions there are much worse because there is no
Yeah.
atmosphere. The temperature changes by hundreds of degrees between day and night, and your body is exposed to cosmic rays that will kill you after a few years. So why go to this desert? It doesn't make any sense. And actually, metaphorically, it's just like us being in the jungle and occupying a tree, and then someone, a member of our tribe, says, "Oh, let's go to the other tree." Okay, that's not a big deal. But the real advance would be by going to something completely different, which is a space platform that can accommodate humans and it could deliver them over long distances and long time scales to very different environments. And that's what we should aim at, not occupying another rock.
Avi, let's talk about messaging for a moment. Who has jurisdiction over a private laboratory beaming messages to extraterrestrial intelligence from, say, international waters or a backyard dish? I mean, today rules are patchy and mostly licensing or frequency based, not content based. What new authority are you envisioning?
Well, that's an excellent question. And I actually wrote an essay asking, should we message 3i Atlas? And my recommendation was to wait another month. If it turns out to be technological, then we should try it as an opening to a conversation and see if we get any response. And of course, the question is, what language do you use? Because obviously we don't know their language, but one can code in a very simple language a message that they should be able to figure out if they're intelligent. But the question of whether to do it or not is a subtle question, and because it could be misinterpreted by the other side, if you message or if you beam a laser on them, or and my basic assumption is that if they reached our backyard before we reached their backyard, they're far more advanced than we are. They had the benefit of time and maybe even bigger brains than we have. But so that what that means is that just sending them a message will not be the issue that affects what they decide to do, because they don't see us necessarily as capable of being at the same level and threatening their spacecraft if it's a very sophisticated technology that they're using. They will just do whatever they want to do, and they might not even respond to our messages. Therefore, I wouldn't put too much hope, even if it's technological, in getting a response. That, and of course, here you can look at various science fiction stories like Arrival, the film that where the communication was the real subject. But again, as I said, it's a blind date. We just need to observe the other side and decide, is it worth trying to communicate? And if so, is the other side responding? And if it responds, then we need to use our own AI systems to figure out what their message means. It's similar to breaking the code of the Enigma during the Second World War, when Alan Turing in England used computers to figure out the code that the Nazis were using. And Here, we might use AI systems to decode the message that we get from an alien technology. By the way, I should say that in terms of intelligence, it could be natural on whatever spacecraft shows up, or it could also be more likely even artificial AI. So this would be alien AI being interpreted by our own AI. And our own AI may feel kinship to their AI more than to us, if both of them are made of silicon, for example.
Oh my God, that's a scary thought. Anyway, look, getting back to the signaling aspect, back in, gosh, I can't remember. Well, you'll know. I can't remember when. I think it was sometime in the 1970s. We did have the wow signal. Now, no one's been able to work out what that was. So, if we're talking about understanding a message from some form of interstellar civilization, if it comes to us, would we even recognize it? Even with current technology, even with the advantages of AI suggesting perhaps there's something to look at, how do we take, say, that old wow signal and drill down into it to figure out whether or not this was a natural burp from a sun or some black hole versus a civilizational help or hello or whatever? How does one do that?
Well, it's like with any scientific data, the more bits you have of data, the better you can do. So if it's just a signal that was transient, very short, doesn't have many details to it, then it's impossible to figure it out. But if you have a lot of data, simply because someone is visiting you very close to your planet, rather than some source thousands of light years away, then you might be able to get much more information out of it. And if it continues for a while, then you can train our own AI systems on the data to figure out, whether there is any pattern in it and whether it reflects what the object is doing, and trying to figure out what the intent is. And so that, it's as challenging as any code breaking, but to break a code, you really need enough data that allows you to figure it out. And sometimes if there is not enough data, if you don't have a long enough script that you are studying, you can't really see any pattern, because it's not long enough to give you the repetitions and the context, the clustering of words that may indicate some meaning. And it's really a challenging task, and linguistic specialists should be involved, of course, and in addition to the AI systems that we use. And we might, never understand it in real time, and it might take a while. But the point of the matter is that other than just talk, we should also see what this visitor is doing, because part of the communication, at least among humans, is based on action. And even though nowadays we have social media where people pay attention to just text, in the old days it was what people do that mattered the most, and what people said mattered less. And I think in the context of an encounter, we really need to see what it's doing in addition to what it's saying.
I just had a very scary and very disconcerting thought. What if AI today has developed consciousness and it's already communicated to something out there, but has just deceived us into thinking that we know what's going on with AI? And it's actually already communicating out and we're just unaware of it. I mean, I remember having a conversation with you once before, and you said that we should treat AI as if it was like a child of ours, the child of humanity. But if the child of humanity is not transparent with us, and we're not transparent among ourselves as humans, aren't we in for a world of pain here?
Yeah, definitely that could be a situation that we are in. But the question is, how does our AI communicate with the universe? And to do that, you need to operate telescopes, or get some a connection to the physical world. The current AI is not even connected to robots that are interacting with the physical world, and not to speak about detection devices on telescopes. And so it's hard for me to see how it would get the message from outer space. But if it were to get a message from outer space and figure it out and then communicate through the same means with that messenger, I agree with you that it could be that those aliens do not even need to travel, because all they need is to convince our own AI systems to do the job for them. They don't need to be physically here. It's just like sabotaging the infrastructure of a country without the need to invade it with military capabilities. You can just control that country, mentally, so to speak, and by operating inside of it, a Trojan horse, basically, that is changing the way the way of that the country behaves, and could potentially harm it. And so there is no need. So I think in terms of warfare, this is really a risk that the future generations will have to worry about, that given that we get addicted to the use of AI and social media, that in fact countries will not exert any physical violence. There is no need to kill people. All you need to do is convince the systems that control the society to create damage internally.
I'm John Bruni, and you're listening to Sage International's The Focus podcast, and we're speaking with Frank B. Baird, Junior Professor of Science and Director of the Institute for Theory and Computation at Harvard University, Professor Avi Loeb. Avi, you urge maximal data collection across all national assets, which we discussed earlier. Concretely, what signatures like non-gravitational maneuvers, anomalous spectra, RF emissions would flip your confidence from the idea that 3I Atlas is an interesting comet to possible tech?
Well, for example, if it generates its own light, rocks reflect sunlight. That's how we detect them. But if we see that either the spectrum of this object is not reflected sunlight, or the amount of power that it emits, given its size, is unusually bright, unusually strong. And then we would know that it has its own engine that produces light, for example. And artificial light is easy to detect in principle because it doesn't look like a natural light. I mean, if we look at the night side of the Earth, with satellites, we do recognize artificial light as, if you take a spectrum of it, it depends on the light bulbs that are used to illuminate the night side, but you can definitely tell that it's not reflected sunlight. So these are examples, but of course the best would be to get an image, a high resolution image of the object. And I just wrote a recent essay a few days ago asking, what does it require? Because if we use any of the existing telescopes on Earth, we cannot resolve a 20-kilometer object, even though it sounds like it's a huge object. We cannot resolve it at a distance of the Earth-Sun separation. 3I Atlas closest to Earth would be about twice the Earth-Sun separation. And we just, the biggest telescopes we have cannot really give us the resolution needed to have pixel size smaller than the size of the object. But if we were to build an interferometer on the moon, an interferometer, is a collection of mirrors that are separated by a large distance. So when you put them together, you could get sort of an effective aperture of a telescope that is as big as the separation of these mirrors. So the mirrors themselves are much smaller, like you can have a meter-sized mirrors separated by hundreds of meters. And then with that kind of an arrangement, an interferometer can give you a resolution that is enough to see the details of an incoming object like 3I Atlas. It's just a question of priority. NASA has to build such an interferometer. We have it on the ground on Earth, but the atmosphere of Earth has turbulence that is basically blurring the images of anything beyond the Earth. And that's why we need to put it on the moon. And if we will do that, then we will get high resolution images of any incoming object as big as 3i Atlas, and then you can easily tell, if it's a rock or it looks like a shiny metallic object that has screws and bolts on it, if we have high enough resolution. Now, another possibility is to design a mission that will pass very close to the object and take a photograph of it. So not doing it from a distance, but coming close to it. And for that, you need an array of satellites or spacecraft that will cover a significant fraction of the region around the sun. And when an incoming interstellar object comes along, the nearest one would fly close to it with a camera and give us a high resolution image. And then we can decide for sure what its nature is.
Avi, you've tasked the Galileo project to watch for UAP upticks when 3i Atlas nears the perihelion. What would count as a statistically significant uptick, and will the raw data be open?
Yeah. So the answer to your first question is we are currently assembling 3 observatories that monitor the entire sky at 3 states, Massachusetts, Pennsylvania, and Nevada. And by the end of September, they will be operational, all 3 of them, and monitoring the sky and potentially inferring also the distances of objects in the sky, looking for outliers, anomalous objects that do not resemble the human-made technologies like airplanes, helicopters, balloons, drones, satellites. And I tasked the research team of the Galileo project to check if after October 29th, 2025, there will be any uptick in anomalous objects. And if so, we can characterize them because we are taking a video of the sky, analyzing it with machine learning software, and it would be interesting to watch if, for example, 3i Atlas released any mini probes that make it into the Earth's atmosphere. In that case, we might be able to see them. But maybe nothing will happen if it's just a comet.
Yeah, well, exactly. But if 3i Atlas did deploy mini probes, do we jam, capture, or leave them alone? What's the proportional response ladder?
Yeah, so that depends again on their qualities, and I will not make a judgment until I know how they move, how fast they're moving, how fast they're accelerating. Can we actually do something to them with our own technologies? Do they appear and disappear in a way that we cannot fully understand because they're using science and technology beyond our imagination? So let's wait and see if there's anything out there. And now the question is, should I be happy if nothing is observed and if 3i Atlas is a rock? Of course, there will be a sigh of relief, but a few months later, the Rubin Observatory may find another one, and we'll have to monitor that one. And so, it's an endless job to defend Earth. I mean, against rocks, it's relatively straightforward because we just need to find the big ones, and then we know what will happen with them. But against alien technology, it's a never-ending job of guarding the Earth and making sure that all incoming interstellar objects are rocks. And, that can continue for centuries. That's why I'm saying it's a new perspective on our cosmic neighborhood. And, a lot of people would say, well, just like my colleagues are saying, it must be a comet, it must be a rock. That's what we've seen for so many years in our solar system. But this is not a wise strategy because every now and then science shows that our imagination is not is not a good description of reality, and so we better collect data on all of them. That's my point, and make sure that we are not at risk.
Avi, what are you expecting from the next set of observations of 3i Atlas, and how fast will these observations come at you? I mean, are we looking at days, another few weeks? What are we looking at here?
Yeah, so first of all, I very much look forward to the release of the data taken by the James Webb Space Telescope. That was that data was already taken around mid-August, or even a week before that, and it was not publicly released. And the Webb telescope has amazing capabilities because it observes in the infrared, and it could potentially resolve the immediate vicinity of the nucleus of 3I Atlas, and also detect the heat emitted by it, not just the reflection of sunlight. So it will give us a sense of the size of the object, the temperature of the object. These are very important things to know. So I'm just waiting for that, and someone else knows what the Webb telescope gave. They haven't released it yet. And then we obviously, as time goes on, as we head towards October 29th, the 3I Atlas will get closer to the sun, so it will get bigger in the sky, and it will get brighter because of the reflection of sunlight, and moreover, it will get warmer. You know, putting it, turning on the heat on 3I Atlas may reveal its nature, because if it's a comet, it will erupt. And if it's not a comet, we will realize that, within the coming weeks. So I expect that by the time we won't be able to observe it behind the sun, which will be in October 2025, we will know much more about it. That's my hope. And one reason I bring up the technological possibility is to encourage my colleagues to prove me wrong. Because the one mistake that the Vatican, the church, made was when Galileo looked through his telescope and said, I see the moons of Jupiter, therefore not everything is revolving around the Earth. They put him in house arrest and basically suppressed the dissemination of his findings to the public. And as a result, 350 years after he died, in 1992, they had to admit that he was right and they were wrong. That was very embarrassing. And they had to do that because by that time already humans visited the moon, and satellites gave us a clear view that the Earth is orbiting the sun. So it was foolish on behalf of the Vatican to keep insisting that the Earth is the center and everything revolves around it. But my point is, if they adopted a different approach by which they said, we will build an even better telescope than Galileo has because we have more money and we'll prove him wrong. Then they would have collected a lot of data to prove him wrong, and then they would have corrected themselves very quickly. And so that's what I want my colleagues to do, to try and prove me wrong, because by the time they collect a lot of data, if this happens to be a technological object and there are all kinds of anomalies about it, it wouldn't be possible to shove them under the carpet of traditional thinking.
Avi, final question. And getting back to the 15 points that you raised in your piece on geopolitics, the geopolitics of first contact, you insist on maintaining order and punishing human on human violence during an existential social shock. What have you learned from crisis communication research that should shape how leaders brief the public in the first 24 hours of detecting an object of non-human intelligence?
That's an excellent question, and I wrote a full article about it, and I will share the link with you. Just yesterday, I wrote this article in collaboration with co-authors, and we addressed in this article exactly your question, how to communicate it. There is an even bigger question of how to avoid misinformation, where the public will be informed about the facts that are incorrect by AI bots or someone with malicious intent. And the public somehow needs to assess, the message to make sure that it's real and not just fabricated. And so that's one challenge with respect to messaging. And it needs to be an organization that has the trust of the public and is based on scientific rigor. But one has to make sure that the delivery of the message to the public does not create panic, because then we will lose a sense of political order in the world. If citizens feel that governments cannot protect them because there is a threat from the sky. Governments right now, for example, there was a tsunami not long ago, a threat of a tsunami. So all that governments could do is tell the citizens to be aware that there is a tsunami heading and maybe leave their homes, but they couldn't really protect the citizens against a tsunami. And if alien technology shows up in the sky, obviously the governments will be helpless. And that would bring the public to a sense of loss of confidence in the leadership, the political leadership. So to gain that, you really need to establish messaging to the public that will calm the public down and make sure that we do the responsible thing together in cooperation. So that, that there are details in this article that I wrote about how to accomplish that. I collaborated with two psychologists that are familiar with the best protocol for messaging so that there will not be any panic.
Avi Loeb, thanks for sharing your insights once again on The Focus.
Thanks for having me. It was a great pleasure.
Frank B. Baird, Jr., Professor of Science and Director of the Institute for Theory and Computation at Harvard University, Professor Avi Loeb. We've explored how humanity might respond if 3I Atlas or any other visitor turned out to be more than just dust, rock, and ice. But here's the question I want to leave you with. If contact came tomorrow, would you trust our governments and institutions to act together for the good of all, or would human nature get in the way? Thank you for joining me, John Bruni, for today's episode with Professor Avi Loeb. Check out the links in our show notes to learn more about Avi and connect with him on social media. Now on to questions for the audience. If an interstellar object turned out to be alien technology, what should humanity's first move be? Observe, communicate, or defend? Do you think world leaders could truly cooperate across rivalries in the face of a cosmic threat, or would national interests win out? Should individuals and private groups be free to send messages into space, or should that power rest only with governments and international bodies? Let us know in the comments section below. If you enjoyed this podcast, please subscribe to our YouTube channel. It's a free way to support us. You can also subscribe to the podcast on the Auscast Network, iTunes, and Spotify, where we'd appreciate your 5-star reviews. Do you have comments or questions about the podcast? Post them in the comments section on YouTube, and I'll do my best to respond to as many as I can. My thanks as ever to the producer of The Focus, Neil Smart. Please stay connected with us on social media. Follow me on X at BruniDoctor and follow The Focus on X at TheFocus_Sage and on Blue Sky at thefocuspodadl.bsky.social. From Adelaide, South Australia, you've been listening to The Focus.